Assalamualaikum and hi everyone. My name is Ahmad Afif At-Tirmidzi bin Muhammad Haris. I am from Group 6. In this video, our group will talk about diode AC representation. Diode AC equivalent is basically diode equivalent circuit for AC equivalent. As you can see in the picture, this is a simple representation of AC equivalent model. According to this picture, for AC equivalent, during AC analysis, the diode is equivalent to RD, and during analysis, you must perform DC analysis first to get ID in order to obtain RD. All of this we will discuss in detail in the next part.
Okay, I will now explain AC analysis on diodes. Before we begin, we have to note that in a AC circuit, the power supply the current in an alternating form configuration. This means that the current go forward, then go backward, forward and backward, something like that. So we have the graph that goes like this, something like that. Okay. Anyway, and we know that the diode only allow current movement to go in one direction. So we have to do something about it, and we have to replace the diode with something. Okay, so for forward bias, we can say that the current is moving in the direction of the diode. So if the diode goes this way, the current also go that way. Okay. This means that the current can flow through the diode because it's in the same direction as the diode. So we change the diode into a short circuit. This is for just analysis. There is different calculation on diode. For reverse bias, the current is going against the direction of the diode. So there is no current flowing, therefore the current is equal 0. And as current equals 0, we normally we replace it by an open circuit. That is why we have an open circuit there. For voltage across the resistor, we can refer to this graph right here, these two graphs. Okay. We can see in the upper graph, the voltage goes like this, something like that. This means that the power supply is supplying in alternating current. And we know that diode does not allow current to go in the other direction other than the direction of the diode. So the reverse side will be like blocked, and this result in clipping of like the negative side of the voltage, like this.
Right. Assalamualaikum warahmatullahi wabarakatuh. So now I want to discuss an example for the SC analysis. Okay, let's see the question first. For the circuit shown in the figure 4, which is here, draw the waveforms of the voltage across the resistance VR and the voltage across the diode VD. So the question wants us to draw the waveform of the voltage across the resistance and diode. So before we are going to draw the waveform, let us calculate for the magnitude of V instead of using the VRMS given here, which is 120 volt as the peak of the waveform. Alright, so Vm is equal to VRMS times square root of 2, and after the calculation we can get around Vm is equal to 170 volt. And then let us draw the waveform of voltage source, and we can get the waveform like down there. Okay, during the positive half cycle, the diode is forward biased, and therefore we can replace it by a closed switch like here. Because it looks like a short circuit, so we can say that voltage across the diode is 0. Therefore, voltage across the resistor is the same as voltage source. Meanwhile, for the negative half cycle, the diode is reverse biased, and therefore we can replace it by an open switch like here. Because it looks like an open circuit, so we can say that the voltage across the resistor is 0. Therefore, the voltage across the diode is the same as voltage source. And lastly, this is the summary for the solution of this question, which is this is the waveform of voltage across the diode, and down there is the waveform of voltage across the resistance.
Just now, Meor just talked about the theoretical example on this topic. Then I'm gonna discuss an example on the mathematical part. In this question, it is given VPS equals to 10 volts, resistance equals to 20 kilo ohm, V gamma equals to 0.7 volt and Vi equals to 0.2 sine omega t volt. We need to determine the current IDQ and the time varying current ID. So if we sketch the circuit with the given value, the diagram will become like this. So in this question, we will ask to search for IDQ, which is the DC diode current, and ID, the AC diode current. The first step is doing DC analysis by turning off AC supply. VPS will be greater than V gamma. Diode will turn on and convert into a battery. Then VD will become equals to V gamma. So if we sketch the circuit again, AC supply will become short circuit here, and this is the VD equals to V gamma. This is the resistor with IDQ, which is the diode, DC diode current. So in order to get IDQ, we need to use KVL formula. We use this direction of current. VPS plus V gamma plus VR equals to 0. So VPS here is negative sign because we use this direction. So it starts with negative. Then it will become negative. Then the V gamma is it is start with positive, then it is positive. And it is the same with the VR. So VR, we use the VIR formula. So V equals to IR. So this is I, this is R equals to 0. Then we get the IDQ 0.465 milliampere. The second step is calculate RD by turning off the DC supply. Then the diode will convert into a resistor. So we get the RD with the formula VT equals to I. We get the RD 0.0559 kilo ohm. The third step is doing AC analysis. AC analysis, we turn off the DC supply. So we get the diagram over here. So this is VI, RD, and R resistor. So we use KVL with this direction of current. So VI starts with negative, so it is negative. VRD and VR, we use the VIR formula. Then we calculate the ID, then we get 9.97 sine omega t microampere.